This is 7-4, factoring ax squared plus bx plus c. So previously, we were factoring x squared plus bx plus c. So the difference is that here a was 1, invisible 1, and on the problems that we're going to do, a is going to not equal 1. It's going to be something else, and so we have to do a little bit more with it. I actually like to call this the AC method, just so that we can link something in our brain to help us remember this long process. This one's a little bit lengthy. So the first thing that we need to do is we need to find AC. We're going to multiply the A and the C. So that would be a 4 and a -5. That -5 is a -5. So we multiply them. So AC ends up equaling -20. And just like we did before where we had two things that multiply to C and add to B, now we're doing two things that multiply to AC that add to B. So in this case, that would be, I shouldn't be using capital letters for that, AC. Oops. So in this case, that would be -20, but we need them to add to 8. So let's figure out what we have here. We've got, you could just start with 1 and 20, 2 and 10, 4 and 5. So those are our options. And this one's going to be able to make it to 8. It's just that one of them has to be negative because it has to multiply the -20. So if you do -2, the larger number will take the bigger, will give us the sign basically. So it's going to be +10 and -2. So before we would just write like x plus 10, x minus 2. It's not that easy this time, but that is what we're finding. So step 2, I don't know if I like what's happening here. That's a lot going on there. Okay, well, I'm just going to make our own step 2. So step 2 now is that you're actually going to split up that b. So 4x squared, instead of writing 8x, I'm going to write the two things that add to 8x. So that would be a 10x and a -2x. Or you could write plus -2, doesn't matter. And then -5. So from there, I have 4 terms now. So it was AC, split the b to get 4 terms. So that's what we've done so far. AC, split the b to get 4 terms. And I've been stressing that with 4 terms, we're going to have to use something. Factor by grouping. So now we're going to factor by grouping, which means that I'm just going to group up these right here. That's really technically a plus sign there. And I'm looking for the GCF, the greatest common factor. So if you still need to, you could do like 4x squared as 2 times 2 times x, like using a factor tree. And 10x would be 2 times 5 times x, and in common we have a 2 and an x. And then we can write what we have left. In the first one it was 2x, and in the second one it's 5. Or you can just think to yourself, the largest I can divide by is 2x, and divide it and get that. Same thing. Now the second group of parentheses, I'm going to take out a -1. So I actually didn't need that plus sign there, but that's okay. So it's going to be a -1, and that's going to leave me with 2x plus 5, which is perfect because we need to have those twins that I have right there and the GCF. So in one group goes the GCFs, that's a 2x and a -1. And in the other group, it's 2x plus 5, the twins is what I like to call them. And step 3 would be to check, actually. So if we check this, you'll actually see why we do this process. So I'm going to go through and FOIL that to check. So this is my answer. Comes a FOIL problem. But I'm going to go ahead and just FOIL or distribute to check my work on that. So I would do 2x times both of those. So 2x times 2x is 4x squared. 2x times 5 is 10x. Remember, we multiply the coefficients, keep the base, add the exponents. And now I'm doing the -1 to both of these. So -1 times 2x is -2x, and -1 times 5 is -5. And what do we usually have to do once we FOIL. Most of the time we can combine like terms. Well, those like terms are the terms that we found over on the left here in our sum after we figured out the product and we got the two numbers for the sum of 8. And so that's what it comes out to be, 4x squared plus 8x minus 5. So it does take me back to the original problem, and you can see now why we split that. That is like undoing the like terms. That's how we ended up with the 4 terms. We really worked backwards to undo the like terms and uncombine them, basically. So I know it's a lot, but we'll keep going with that. Here's another example. So now, again, step 1 is the AC. So we're going to do that. 3 times 10, which is 30. And so you can make a little table if you need to. We need 2 things that multiply to 30 that add to the B, the negative 11. So 2 things that multiply to AC that add to B. I need to really use lowercase here. Okay, and then, so I could just start listing it. 1 and 30, 2 and 15, 3 and 10. 4 doesn't work, 5 and 6. And you could see that it could be 5 and 6. So in order to add to the negative 11, they're both going to have to be negative. So those are my terms, negative 5 and negative 6. Remember, we need to split the B. Split the B so that we have 4 terms, which means we're going to use factor by grouping. Okay, so that would be the first 2 terms. The first and the last one, let me highlight them for you. The 3x squared and the 10 remain the same. It's just the B that was split up into 2 different terms, which are negative 5x and negative 6x. So 3x squared, and I know it has to have the x here, the negative 5x and the negative 6x, because it was supposed to add to the negative 11x. That's where that was coming from. So it was 3x squared negative 11x plus 10 originally. So I split it into that, and then now I have my plus 10 at the end. So these 2 terms actually remained the same, the 3x squared and the 10. I was only splitting the B. Okay, so now factor by grouping. So what can I take out of 3x squared and negative 5x? Well, I can't divide them by the same number except for 1, but I can take out an x out of each of them. So that would be our GCF, and we would have left 3x minus 5. Now you can kind of cheat and know what you need to divide by in this second part to get that 3x minus 5. So what could we divide these by to get the 3x minus 5? And that would be a negative 2, because we need it to come out to be positive 3, and 10 divided by negative 2 is negative 5. So now I can write my final answer, I'll put it in red here, would be x minus 2 and 3x minus 5, the GCFs, and what I like to call the twins. And I'll do another one for you. So let's factor this one. Again, AC, so that's 2 and 12 becomes 24. So, let me zoom in. 2 things that multiply to 24 that add to 11. I already know it's 8 and 3, but if you didn't know that, you would make your table, which would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Sorry about the birds behind me. And I think that takes care of that, but we see right here that, oh, that's not what I want. Wait, multiply to 24 and add to 11. Yes, that is what I want. That's why I probably should do this. 24 and 11, that's what we wanted. Oops. And so I'm going to take those positive 3 and positive 8. So now that I've done the AC, which was 24, I'm about to split the B. So instead of 11x, I could do like 8x plus 3x or 3x plus 8x. The order there doesn't matter. And remember, I'm keeping the 2x squared and I'm keeping the 12, the x squared and the c. So I'm just going to bring those down. Okay, now factor by grouping. So I take my groups, pull out the GCF, which happens to be 2x. So on the outside I get 2x, and on the inside I have x plus 4. Same thing, I know that I need to end with x plus 4, so I already know I'm going to divide by 3. But you could just see that the GCF is 3 and then do it that way, kind of doing it backwards. So now we have 2x plus 3 as the GCF and x plus 4 as our twins. If you FOIL that, you will get back to the original problem.